Okay, chapter 1.5, part 3, continuing. So identify parent function f of x of this and describe how the graph of g of x, f of x are related. Okay, so that's regarding where are we starting from. Are we starting from constant x, absolute value of x, greater integer x squared, x cubic, square root of x, cubic root of x, power function or rational function? Well, if you look at it, x is on the bottom. So you should know, okay, there's only one parent function with x on the bottom. It's like this. So 1 of x is a parent function. So we are starting from 1 of x. That's a parent function. And 3 over x, you should be able to look at that as this. That's exactly the same as 3 times 1 of x. Now my question. What's the difference from 1 over x to this? We multiply by 3, didn't we? We multiply by 3. So you should know, multiply by a positive number has a thing to do with the stretch or shrink. Then you question, can x see 3? Answer should be no. X cannot see 3. So if some of you, what do you mean? Right here. If you have a 1 over 3x, x can see 3? Yes. This one, x can see 3. X can see 3 here? No. X is on denominator. X cannot see anything outside of denominator. Okay? X cannot see 3. So you should remember x cannot see number. It should be vertical. Vertical. Stretch or shrink. That depending on value of the number. 3 is a big number. So vertical stretch. Okay? Vertical stretch by 3. They use the word expansion. Same thing. Vertical stretch by 3. That's the answer. Graph-wise, you grab it, stretch it, so all y value will be multiplied by 3. That's going to be the graph. Again, if some of you say, well, I'm going to graph this using graphing calculator, 1 over x. Also, I'm going to graph this using graphing calculator, then I'm going to compare. Well, if I let you use your graphing calculator, you can, but I'm telling you, it's going to be not easy to tell. When you look at the graph, this versus this, right? How do you know it's a vertical stretch by 3 or is it horizontal? It's hard to tell. So graphing calculator can be very useful for, I would say, shifting, reflection, detecting stretch shrink is very difficult. Sometimes it's actually impossible. It can be horizontal, it can be vertical. So you need to know how to deal with that in one equation. I'm trying to tell you. Okay. Identify the parent function of this. Okay, only one graph has absolute value function. So parent function should be absolute value function. That's your parent function right there. Then they're asking what happened here. Okay, so be very careful. This one, we are dealing with more than one transformation. Actually, there are 2 transformations. So you can see 4. We multiply by 4. So you should know, okay, multiply by 4. Multiplying is stretch or shrink. Then you should ask, okay, it's a stretch or shrink. X can see 4, yes or no? Yes, X can see 4. X can see that's horizontal. 4 is bigger than 1, horizontal shrink or stretch. Bigger than 1. So if you look at the chart, bigger than 1 is a horizontal compress, which is horizontal shrink. So you should know it's a horizontal shrink by what? It's not horizontal shrink by 4. You cannot shrink by bigger number. 4, you have to flip it. It should be a horizontal shrink by 1/4. Did they say that? Yeah, that's wrong. Horizontal by a factor of 4 is completely wrong. Don't do that. So you say horizontal shrink by 1/4. Okay? horizontal shrink by 1/4, then you're dealing with a -1. Okay, this -1, if you compare here to here, we multiply by -1. So you should know, multiply by -1, you should realize, okay, that's something to do with the reflection. X can see -1, yes or no? No. X can only see inside the absolute value. The -1, X cannot see. So if you look at X cannot see, that's a reflection over X-axis. So you say reflection over X-axis. So your answer should be this, and you say reflection over X-axis. So there are two answers for that. Graphing, so you're gonna reflect it. You're gonna reflect it, and every X value, you will multiply by 1/4. It's going to shrink, horizontally shrink by 1/4. So for example, this coordinate was what? 4, 4 here. So when you flip over x-axis, that becomes what? 4, -4. And horizontal shrink by 1/4. Every x value you multiply by 1/4, it will become 1, -4, because 4 times 1/4 will make it 1. So it's going to shrink. That point becomes this point. So again, if you say, well, I'm going to graph this. I'm going to graph this on the graphing calculator. Then I'm going to compare. You might be able to tell the reflection, but stretch or shrink, I'm telling you, it's almost impossible to detect from graph. Okay, next question is graph a piecewise function given this. So we have a 3 function definition, piecewise function, depending on this, and you're supposed to graph it. So let me just do that. You can look at me how I do this. I will just do here. I need okay. So first graph, y equal to absolute value of x plus 2. Okay. So you should be very familiar with this. Absolute value of x looks like this. Plus 2, x can see 2, yes or no? Yes. So it's about horizontal. Plus 2, you remember? You gotta go opposite direction. Left by. So I know 1 to the left. My graph should look like something like this. Move to the left by 2. Okay. So I know I'm starting from here, V shape. I'm gonna go up like that. I have a V shape like this. Okay, that's gonna be my graph. If I connect all those, that should be V shape. But you have to be careful. If you graph the whole V shape, that's absolute value of this. But we have a condition. X is less than 0. What does that mean? X equal to 0 is right here. X equal to 0 is right here. Less than 0 means left side of that. What does that mean? Right side, we are not taking it. Only left hand side. So only left hand side becomes live. They are live now. Right side is they are dead. Dump it. You are just getting rid of that. Now, if you look at this, absolute value of x minus 2. So let's study that. Absolute value of x minus 2. So compared to original, -2 is down by 2. What does that mean? 1, 2 down. So graph should look like something like this. So you look at this, so you get down by 2. So my graph should start from here. I'm gonna go V shape from here. So you're gonna go to the right, you know, to the left, so you overlap here. That's my entire V-shaped graph. But you're only taking from 0 through 2. 0 for x value through 0 value, 2 to x value. You're only taking from here to here. So only this portion survives. So this part, you're dumping it. Erase it. Dump it. Okay, here x equal to 0. X equal to 0. There's equal sign. So you make a solid dot. X is less than equal to 2. We have solid dot here as well. I don't know if you noticed, if for previous x is less than 0, there was no equal sign. That's why I did not make this. I made an empty dot. So what is this? Square root of x minus 2 plus 2. Do you remember? Square root of x graph is this. You start from the 0. You go 1 to the right, 1 to the up, and look like something like this. That was the graph. What is minus 2 doing here? You go right by 2. That's right by 2. What is this plus 2 doing? Up by 2. So from here, you should know I go right by 2. 1, 2. You go up by 2. 1, 2. From there, the graph should be something like this. So I go right by 2, up by 2. So starting from here, I'll go 1 to the right, 1 to the up, and graph should look something like this. But you're not taking entire, you're taking x is greater than 2. X is greater than 2. So there's nothing on the left, so it works perfectly. I don't have to dump anything. Only thing is, you see here, greater than 2, there's no equal sign. So I need to fix this x equal to 2 as an empty dot. Okay, that's how you do piecewise function. And that was my work. Okay, so pause the video, block it, try to do this exercise by yourself. See if you can do it. Here, I'm gonna do that together with you. So first one is x plus 1 square. So I'm starting from x square. X square looks like parabola like this. The plus 1 is what? Left one. We go left one. So I got the idea. So here, let me just do this. Left one, so you are starting from this point. You go 1 to the right, 1 to the up, 1 to the left, 1 to the up. You go to the 2 to the right, you gotta go 4. Because if you plug in 2, it becomes 2, 4, 2 square equal to. So I know you go 2 to the left, you gotta go up 4. So your graph would look like something like this. Where's the x is less than minus 1. X is less than minus 1. Okay, you're only taking left hand side. What does that mean? Right hand side, dump it. And so my graph would look like a curve like this. There's no equal sign, so make sure the end point has to be empty dot here. Next one is x squared minus 1, minus 2, I mean. Okay, so x squared minus 2. So from this, you gotta go down by 2. That's not that bad. So down by 2, I have a graph here, 1 right, 1 up. 1 left, 1 up. I go 2 right, 4 up, 2 left, 4 up. So I'll have graph something like this. Okay, minus 1 through 2. Minus 1 through 2. Minus 1 through 2. So only this portion. That works good. Okay, So you're dumping you're dumping here, you're dumping here. Okay, equal sign, both ends are solid. Solid here, solid here. Square root of x minus 2. Okay, so again, square root of x means like this. So minus 2, you gotta go right by 2. Go right by 2. That's not that. So you go right by 2 here, right one of 1. So your graph should look something like this. Actually, passes there, but okay, if you look at x is greater than 2, I don't have to dump anything. Greater, there's no equal sign at end point. So let's fix that to empty that. Okay, that's how you end up with that. If you have graphing calculator available, you can graph each using graphing calculator. You can type that in, you can look at the entire graph. You can also look at the table. That can help you better when you try to sketch it. You can looking at the graph, looking at the table, you can graph it and cut some certain part of the equation. Some of your graphing calculator might even have a piecewise function available. You can just type it in as it is and just show you the whole picture like that. I'm training you to graph this without graphing calculator. Okay, transformations with absolute values. So question is, what if this is your original function f of x, and if I ask you to graph this, which is taking absolute value to the whole f of x. So concept-wise, this is what it is. F of x is equal to y. F of x is y. So when you take absolute value on y, you know how absolute value works. If you put inside absolute value positive value, nothing changes. What does that mean? If y value itself is a positive, you take absolute value on it, nothing changes. What does it mean y value being positive? That means they are above x-axis. So graphically, any portion of the graph above x-axis stays same. What happened to the graph, portion of the graph, which is below x-axis? Below x-axis has a negative value of y. So what happens when you take an absolute value with a negative value? If you take absolute value and negative value, it becomes a positive. So if you take a negative y value and take absolute value, it becomes a positive. So any negative y value here on the graph will become positive y value. So you might say, I have no idea what you're talking about. Well, don't worry about it. If you did follow, I just explained the logic behind it. If you did not quite understand what I just talked about it, this is what all you have to do. If you see this notation, this is what you have to do. Leave portion of the graph above x-axis. Any portion of the graph above x-axis, do not touch it. Portion below x-axis, flip over to top over x-axis. So this one, memorize it. If I ask you absolute value x on everything, absolute value of f of x, what do? Anything above x-axis, leave them alone. Anything below axis, make sure you flip over to the top. Then that's the answer. Okay, what happens if I ask you f of absolute value of x? So you need to understand the notation difference between this and this. That's a different notation. If you take absolute value on x, what does that mean? That means X value, let's say this is the original graph, f of x. So if you plug it in x value is positive, you got function value. If you plug in x value is negative, you got function value. But this is what's happening. If you put absolute value on x value, what happens if you plug it in x value as -1? If you plug in x as a -1, -1 take absolute value on it, it becomes 1. So you might say, what are you talking about? When you plug in x value as -1, -1 disappears. Instead, 1 is replaced. So basically, any function value related to minus just vanishes, disappears. And whatever that value is replaced by positive x value, which will be same result as reflected to y value. Okay, so any negative x just vanishes. So on this graph, any negative x value means anything left side of the y-axis just disappears, completely just disappears. And that portion of left-hand side will be replaced by whatever on the right-hand side, you flip it. Okay? So here's what you need to do, what you need to know. If you see this notation, what do you do? Get rid of left side of y-axis. Any portion of the graph left side of y-axis, boom, gone. Then flip over right side to left side. Okay. Left side graph gone. Whatever on the right, flip it. Of course, the right hand side still stays there, but flip it, it looks like a butterfly figure. Okay, so you do need to know how to deal with this. Then application is not that bad. Use the graph of this. This is a graph. Graph this. Okay, is that this or this? That. What do you do? Leave top part alone. Anything above, leave them alone. What about bottom? Flip it. So you should know the new graph should be this part. This one is your answer. Right here. That is your answer. Okay, I'm asking you to do this. What is that one? That's this guy. You remember? Everything on the left disappears, right? Just flip over. So everything on the left disappears. Okay, this part is all gone. Now that part you're gonna flip over to the over y-axis. So your graph should look like something like this. It should look like something like this. That should be the answer. Okay, I'm asking you to do the same thing, this one and this one. Pause the video, please. You do it. So this one is what? Leave the top portion alone. Bottom, you're flipping over. So that's this one. That one, dump everything on the left. Okay, and whatever this is left over, you're gonna flip over, and that should look like this. Okay, that's your homework.